Thank you guys for joining me today. The topic of the discussion we're going to be talking about today is fire. We're going to be talking about the classifications of fire. We're going to be talking about the fire triangle and the tetrahedron. We're going to be talking about combustion and combustion efficiency. And we're going to be talking about flames and their relation to smoke itself. So let's get started with the classifications of fire. We have 5 different classifications. We have Class A, B, C, D, and K. Class A fires are ordinary combustibles. This is your wood, your paper. These types of fires, we like to cool the fuel. Water is the thing that's most readily available, and water is what we use the majority of the time. Class B fires are fires that involve flammable liquids and gases. With these fires, we like to remove the oxygen from the fuel or keep the fuel out of the combustion zone. So we smother these fires. We use different types of fire retardants, different types of foams. Class C fires are electrical fires. Oftentimes, once we disconnect or remove the electrical source, the fire goes out. Sometimes they turn in at that point to a Class A fire, ordinary combustion, and we use water to extinguish those. Class D fires are metal fires. We use dry powders, sand, sometimes large amounts of dirt to take care of these types of fires. Our last category is the Class K fire. Class K fires are cooking fires, specifically vegetable oil fires. Now, these fires, let me look at my notes because the word is tricky, but we use substances that produce saponification. And basically what that does is it turns the vegetable oil, or whatever oil we're dealing with, cooking oil, into a soap type of product, which will extinguish the fire. Premixed and diffusion flames, these have to do with when the oxygen or air is mixed with the fuel. It happens either at the combustion zone or it happens before the combustion zone. Fuels that are mixed with oxygen at the combustion zone, those are diffusion flames. Now those flames, an example would be a candle. They're kind of lazy flames, very orange in appearance. As compared to the premixed flames, the air is mixed with the fuel before the combustion zone. A cutting torch would be a good example of this. Flames much hotter. You could direct it much or way more accurately. And the appearance is kind of a bluish or very blue flame. Combustion and combustion efficiency. Combustion basically is the process of burning something. That is combustion. Now, combustion efficiency, I'll read you the definition. It's defined as the ratio of heat released by the fuel to the heat input by the fuel. What does that mean to us? Basically, it's how well something burns. How much of the product will get burned up versus how much unburned byproducts there are in a substance. The fire triangle and the tetrahedron. The new thing is the tetrahedron. The only difference is they've added a component to make it a 4-sided figure now instead of a 3 like the triangle. The 4th component is a chain reaction. So heat, oxygen, fuel, and a chain reaction. That is what is required for the tetrahedron for combustion to take place. Last thing we're going to talk about is smoke and flame. You could tell a lot about what's burning by the smoke. The intensity of the smoke, the color of the smoke. You can tell how fast the fire is burning, what stage the fire is in, and your biggest hazard with smoke is the inhalation aspect of it. Smoke contains a lot of byproducts of combustions, a lot of which are hazardous to the human body. Thanks for joining me today.